Okay. So this class. Okay. So in this class, we will cover 7 things. And the people who designed this room, they don't never give lectures. So they don't know that the lecturer needs to see the slides. So, so basically the idea is that we will talk about 7 things: physical media, switching, internet, how it is organized in the edge and the core. Then we'll talk about performance measures, delay, loss, throughput. And then we talk about protocol layers and the network security basics, and then the history of the internet. So first of all, what is a network? A network generally has more than 2 nodes. If it is 2 nodes, we don't call it a network. All right? If you have 3 nodes, we call it a network. And so as shown here, we have this computer, that computer, and then there is a router in between, and there is a server. So there are 4 nodes actually. And so that's a network. On this line here, we have only 2 computers connected to each other. And that's actually what we call a link. All right. So all of you have seen networks because you use networks at home as well as at office. Now every home, and many homes actually, let me put it this way, have their own servers, and you have at least a DSL box which has a switch and so on and so forth. So you have a network at home. And so now you understand the difference between a link and a network. Few more things. End system. So a network can have things in the middle or could have at the end. So these are the end system. This server is an end system. This computer is an end system. This router is an intermediate system. Okay? And so a switch or a router, they are always in the intermediate system, and so end system, and they work slightly differently in the sense that the end systems really don't know much about routing, and the intermediate systems really they have to work about the routing part, right? So the routers and the switches are the intermediate systems. Hosts, we use the word host. It's an old name, so basically it's more historical. So it's the same as end system. So when we say host, we mean either the server or the computer. A gateway is the old name for routers. So when you go into Windows XP and they say default gateway, they mean default router. Okay? Server. Server is a system that provides a service. So you might have a print server, a web server, file server, and so on and so forth. So those are the servers, but they are like any other end system, except that they have some programs that are generally not found on the normal end systems. So servers that provide, so you could have print server, mail server, and so on and so forth. Clients, and anybody who uses those servers are called clients. And then the links that connect the system. So here in this picture we have 2 links. One link goes from this computer to the router, and the second link goes from the router to the server. Right? So this system has, this picture has how many end systems? 2. How many links? 2. And how many intermediate systems?
1.
Just 1. Good. All right. So finish that. Now we talk about the media. Now this part is actually not done very well in the book. So listen carefully because I am going to say more than what is in the book. So the media could be either guided or unguided. Guided means that the signal does not come out of the media. It is somehow we tell it how to go. So in this cable, when I turn it around like this, it is guided because the signal goes like this, right? So it goes exactly where I tell it. Whereas when it goes on the wireless, we cannot guide it, it just goes everywhere. Right? So guided signal, guided media are twisted pair, and we call it twisted pair because if you really open this cable up, or if you come closely and look at this cable, and I'm sure your table has a cable here, I don't know what is inside this box. Just the power. Okay. Wow. In 2011. Anyway, so if they had a internet connection, and some places I've seen internet connection on every desk, and so if you notice this cable, it has wires which are twisted on each other, right? So the pairs are twisted, so that is called twisted pair. Coaxial cable is the one that you use for video in homes. You know, if you see coaxial cable, and I actually have slides later on showing all this. And optical fiber, which you must have seen some places, but so those are the guided media. Unguided are microwaves. So, has anybody seen microwave? No? So by the way, believe it or not, Wi-Fi is microwave. So it's the same thing that you use for cooking. Yeah, believe it or not, I'll show you in a minute. So microwave is unguided signal, wireless is unguided signal, satellite is unguided signal. Satellite, you know, sometimes you get a signal from satellite like TV and all that. Now this picture is not in the book again, and this is important to understand because whether it is guided or unguided, all of these signals are what we call electromagnetic signals. Okay? Electromagnetic. So everything, whether it is electricity or light or radio, television, all signals are electromagnetic waves of different frequencies. The only difference between them is the frequency. All of them are the sine waves, like we talked about sine 2 pi ft plus theta, right? All of them are sine waves, and when you have a sine wave, you can measure the distance between, you know, how long is one cycle. We call that wavelength, right? So all they differ is in the frequency and therefore in wavelength. So if you get house current, and house current has a frequency of what? 60 hertz. That is 60 cycles per second. That's sinusoidal too, right? Then you move up and you start listening to the radio. You might be listening to short wave or long wave or something like that, but they're all here. From 100 kilohertz to 10 megahertz or even 100 megahertz or something like that. Okay, that's radio. Television uses something from 10 megahertz to 700 megahertz all the way up to 1 gigahertz. Satellite uses 1 gigahertz onwards. And when you use optical communication, a good example is remote control. In homes, you have a remote control that produces some kind of red light, right? And so that is infrared remote control, right? That's also our electromagnetic signal just below the red, and just above the violet is called ultraviolet, and this is visual light. So basically all of these things are electromagnetic signals, and they all behave somewhat differently and somewhat similarly. So it's important to know which part of the spectrum you are in and what you are doing. So talking about microwaves, so for each signal there is a frequency and there is a wavelength, and you can say it by anything. Sometimes when we are at the lower end, generally we talk by frequency. When we are at the higher end, the frequency becomes so high that we start talking about the wavelength. So here when I asked you what is the house current, you wouldn't say that the house current is one that has a wavelength of 10⁻⁷ meters. Nobody knows that and nobody cares for that, right? We know 60 hertz. But when we talk about the light, we say that I have a light which is 600 nanometer wavelength. Okay? But they are equivalent. Wavelength times frequency is equal to speed of light. Right? So everything multiplies to the same number. Speed of light. So anyway, so these frequencies here, starting from here, they are called microwaves. Okay? They go all the way up to 1 micrometer or 100 micrometer. They are called microwave. So those are the ones that are used only mostly in wireless. Okay, they're also used for cooking, but that's a different thing, right? But basically, this is called low frequency, this is called high frequency, this is called microwave, and so there are names for each band. But important thing to notice is that all of these, so electricity goes through the wire and so on and so forth, they are electromagnetic spectrum. Okay? Any question about this? So now we are going to send the signal through the twisted pair. The question is, why do we twist? Basically, if you put two wires next to each other, they are both going to be the antennas. They are going to be antennas which are going to transmit, anybody can listen. But that's what the antennas are all, basically they are simple piece of wire. Right? And when the electricity goes through the simple piece of wire, it just radiates into the air, and therefore it starts affecting every other signal. Right? So if you are trying to send on two wires pairs, this will transmit and this will receive and this will receive and this will transmit, and there will be a lot of interference. The way you minimize that is by twisting them together, and so we take two of them, positive and negative, and we twist them. More you twist, the less interference into other cables there will be. Not only from them to others, but also from others to them. All right. So all the pairs that you use for communications are twisted. And then you take many pairs and put into a cable. So this cable, for example, has 4 pairs, 8 wires. Okay. So this is 4 pairs, 8 wires. And so we might just, for example, use, and each pair has some function, so we won't go into that detail. But basically, if you similarly see a phone wire has 2 pairs. Some phone wires have 3 pairs. Okay? And some phone wire might even have just 1 pair. So you really need only 1 pair for the phone. But most homes are wired with 2 pairs, which means you can have 2 phone lines. And some homes are wired with 3 pairs, they can have 3 phone lines, and so on. Okay, but the Ethernet has 4 pairs. All right. So twist decrease the crosstalk. Neighboring pairs have different twist lengths, and most of the telephone and network wiring in home is twisted pair. So before this twisted pair, let me go to next slide. So there are 2 kinds of twisted pairs: shielded and unshielded. This is unshielded. There is no sheath around it. If you have a shielded twisted pair, they will put a wire mesh around it, and that will make it even more resistant to interference. So if you look at the video cable in your home, the one that comes from the dish or some other thing like that, that has a shield. That has a wire mesh around the cable, and that is shielded twisted pair. Well, actually, the home thing is not twisted, so it is shielded, whatever it is, shielded cable. So when we initially invented Ethernet back in 1978, and I was part of the first team at Digital, so at that time we didn't know this. We didn't have this kind of cable. We didn't think that you could use this for anything. So we had shielded cable, and the shielded cable has a sheath, this thing, this plate, the metal thing around it, and therefore it is kind of thick. It's very thick, very difficult to turn it, move it, or bend it. So those days are gone. We don't use it anymore. All right, those are more historical now. Shielded twisted pair, we don't use it unless you really want to multi-gigabits or something like that. But nowadays the technology has improved in the last 30-40 years, such that we know how to send gigabit even through this wire. Previously, when we started, it was a challenge to send 10 megabit. Challenge to send 10 megabit through unshielded, so we didn't. But 5 or 10 years later, we could send 10 megabit through the unshielded. Then we could do 100 megabit. Then we could do a gigabit. Then we could do 10 gigabit. Today we are working on 40 gigabit and 100 gigabit per second. So as the technology improves, as we get better computers, we get better signal decoders, we get better coding, we can do more and more. Yeah.
Sorry, something. So is there a reason they charge me more for like 12, 18 gigabits?
Yeah. The question is why they charge us more for 12 or 18 gigabit. You see, they are saying spending the same amount in electricity. It doesn't really. I don't think it makes a difference whether you are sending 12 gigabits or electrical power signal doesn't go. But the reason they charge you more is because everything. So they pay more. See, what happens is when somebody is storing the information, they need to have bigger disk if there is more information, right? So AT&T is not storing the information. But what happens is when AT&T has to send the packet, they have to give it to some other carrier. And those carriers are charging by the bits. And they are paying by the bits. So the whole business is based upon the bits, how many bits you have sent. So that's how you get pay. You also pay more for the bits. And also, the equipment that works at 10 megabit can be obtained for $10. The equipment that works at 100 megabit is more expensive, right? And so they have to buy more expensive equipment to offer you better service. That's why it is more. All right. So now you understand shielded and unshielded. Shielded means there is a wire mesh or wire plate or wire something or metallic something around the cables, and that protects the cable from interference. And that was used initially actually more in token rings, and those are all gone. Even token rings are gone, so it's all history. And we will talk about what is a token ring when we come to that point. But nowadays everything is unshielded, whether it is Ethernet or telephone, and therefore there is interference. Okay, question.
For unshielded wires, can you listen into what's being sent since there's not much insulation between the wire and the outside? If you're wrapping something around, or do you actually have to get down to the wire?
I'm sorry, what can you do?
Can you listen into what's being
sent? Okay. The question is, can you listen into? Yes, you can listen into this. You see, because this is unshielded, it can cause interference. Basically what it means is that this is an antenna, right? And so yes, you can listen, but it is not so easy in the sense that I and you probably cannot do it, but CBI can. I mean, CIA can. Yeah.
If you were to listen in, do you have to intercept the signal, or can you get still put through?
I'm sorry, what?
Do you have to intercept the signal that's going through to listen in?
Of course, that's what listening is, right? The definition of listening is
the signal away from the end it was intended for.
How close would you have to be?
No. So you are saying that can you get the signal that is not intended for you? Is that what you said?
No, it's
okay. All right. So the thing is, this is a transmitter, but it's very weak transmitter, and an ordinary receivers cannot receive it. But if you design a very sensitive equipment, especially designed for this, yes, you can. Okay? All right. So we go to the categories. Now, unshielded also comes in many different categories. And this is again not in the book, but I think it is important to know. Because if you go to Home Depot and buy the cable, they sell you Cat 6 cable. And then you are a networking guy and you don't know what is Cat 6. So what is Cat 6 cable? Originally the cable was all Cat 3. Cat is category. Cat means category 3, which is lower category, which could handle only up to 16 megahertz signal. Over that it will just lose it. Then came Cat 4, then came Cat 5. Cat 5 is what generally the Ethernet cable looks like. Then came Cat 5e, which is Cat 5 enhanced. Now we have Cat 6, category 6. So that's the best cable today available on the market. Some places you might find Cat 7, but that is not generally what is available on the market. If you wire your home today, just get Cat 6. I mean, don't get Cat 5 or Cat 4 or anything like that. Cat 4 obviously doesn't work, but don't get Cat 5 today because 2011, Cat 6 is the one that really is working, and it will be out of date 4 years from now. We'll have Cat 7, Cat 8, and then you will say, oh, my house is old. But that's normal, okay? All right. So these are basically higher categories means better, okay? And that's all there is, and there are all these numbers. You don't have to remember as to what is good for what. All you have to remember is that Cat category means better. Basically, Cat 5 is better than Cat 4, is better than Cat 3. That today we have Cat 6. Actually, this slide doesn't say Cat 6, but yeah, it says Cat 6. So we have Cat 6 and Cat 7. Cat 7 is not generally available. Cat 6 is what is there, okay? So we'll